When you hear the word force, what comes to mind? Perhaps the act of forcing someone to do something against their will, a coercion of some sort. That's not what we're talking about today.
When you push a chair across the floor, what's causing the chair to move? Moreover, what is keeping the chair from floating into the air, like a balloon? In the same line, why isn't the chair falling to the center of the earth? Why does a chair with wheels move further with the same push than a chair without wheels? When you tug on the ends of a piece of string, why can't you pull it forever? What's keeping the string straight? We've all played around with springs before. When you compress it, or stretch it, why does it bounce back to its original form once you let go?
Today, we're going to be answering these questions. All of these phenomena can be explained by forces in physics. Now, let's take a step back. What is physics? Physics is the branch of science that deals with matter, energy, and the interactions between them. Now, what is a force? A force is basically just any push or pull from one object to another. So, how many forces are there? In this video, we're going to be covering
Gravitational, friction, normal, tension, spring, and applied force. Perhaps the most straightforward are applied forces. An applied force, represented by F subscript APP, is simply a force that is applied onto a person or object. This applied force can come from anything that can exert some sort of push or pull, like a person kicking a ball or picking up a book. In the case of our chair being pushed across the floor, the applied force is the push exerted by us onto the chair. Gravitational force, represented by F subscript G, is a force caused by objects with mass. It is a push or a pull towards the center of an object. Every day we experience the gravitational force of the Earth pulling us toward its center, or from our perspective, downwards. But did you know that we are also pulling the Earth towards us? In fact, everything in the universe with mass is pulling everything else with mass towards each other. However, since some objects are so much more massive compared to others, we only experience the strongest ones. Going back to our chair, now we know why it doesn't just float into space. It's because the gravitational force exerted onto the chair by the Earth is keeping it grounded. Next up is normal force. Denoted by F subscript N, normal forces exist perpendicular to surfaces in contact. In the case of our chair, since its legs come in contact horizontally to the ground, a normal force going vertically upwards is exerted onto it by the ground. The normal force opposes the gravitational force pulling it towards the center of the Earth, which is why the chair remains grounded. Friction force, denoted by F subscript F, exists parallel to surfaces. When atoms rub past each other, the contact between them causes the objects to decelerate. A chair with wheels experiences less friction force than a chair without wheels. That's why when the same amount of applied force is exerted onto both types of chairs, the one with wheels ends up traveling further. The chair without wheels is exposed to a significantly greater amount of friction, which causes it to decelerate or slow down much faster. Tension force, represented by F sub T, exists along a spring, rope, chain, or similar object when they are taut. It is the force an object experiences when it is stretched, and once stretched to its limits, the force that prevents further stretching. When a string is stretched, it can only be stretched to a certain point. When you touch it from the sides, you can tell that there is a force keeping it taut. Lastly, we have spring force. Denoted by F sub S, spring forces exist along a spring when it is stretched or compressed. When we compress a spring, once we let go, it returns to its physical state prior to the compression. Likewise, when we stretch a spring, to a certain point, once we let go, it also returns to its physical state prior to the stretching.
Now, we know 6 of the most common types of forces that we experience in our everyday lives.